Welcome to the Deep Dive. Today, we are focusing on one of the most volatile injuries you can get, traumatic brain injury, or TBI.
Mm-hmm.
And we're not just talking about a bump on the head. It's a defect in brain function caused by some external force. It can range from, feeling a bit confused,
Yeah,
right up to severe damage that's, well, immediately life-threatening.
absolutely. And the big question we're digging into today is what actually determines if a TBI is mild, moderate, or severe? We're looking at a specific study here.
Right.
469 adult patients. This was in Baghdad between 2016 and 2017. So our mission, really, is to see what factors flag the most dangerous outcomes.
Okay, and the main tool for classifying these TBI severities, it's the Glasgow Coma Scale, right, the GCS.
That's the one, yeah. It's pretty standard worldwide.
So how does it break down?
Well, it puts TBI into three main buckets. If the GCS score is high, like 14 or 15, that's considered mild TBI.
Okay.
Then you've got moderate, which is a score between 9 and 13.
And the really critical one.
That's severe TBI. Scores from 3, which is the lowest possible, up to 8.
And the stakes there are incredibly high. I mean, the source mentioned mortality for severe TBI can approach, what, 40%?
Tragically, yes, it's close to 40%. When you're looking at risks that high, understanding the predictors for landing in that severe category, it's absolutely crucial for prevention, for triage, everything.
Okay, so let's jump into the findings from this specific group,
Yeah.
the 469 patients. Average age was around 42, 43.
Yeah, 42.6 years, plus or minus about 13 years, so a decent spread.
And the overall severity breakdown in this group.
So just over half, 51.4%, had mild TBI, moderate was about 21%, and then severe TBI made up a pretty big chunk, 27.5%.
Almost a third, nearly.
Yeah, a significant portion.
Okay, demographics. What stood out there?
Well, the first thing that jumps out is the gender imbalance. It's quite stark.
How so?
The vast majority were men, over 81%. The male-to-female ratio was like 4.45 to 1.
Wow, is that typical?
It's often seen in trauma data, yeah. But what's important here is the statistical link they found. Severe injuries were significantly more frequent among the men compared to the women. The p-value was 0.014, so quite strong.
And did the researchers have theories why?
They mentioned a couple of possibilities. One was maybe social or cultural differences affecting risk exposure.
Okay.
But the other, and this ties into what we'll discuss next, is that maybe males are injured by, quote, more violent mechanisms, things like high-speed car crashes.
Ah, so it's less about being male, perhaps, and more about the type of incident.
Exactly. The force involved seems to be the driving factor, not necessarily gender in itself.
Interesting. Now, before we get to the mechanism, you mentioned something surprising about age.
Hmm.
Or rather, not surprising in the way you'd expect.
Right. You'd sort of instinctively think older people would fare worse, maybe end up with more severe TBIs. And often, in general TBI studies, that holds true. Complications are higher, recovery slower. But in this specific study, looking purely at whether the initial injury was classified as mild, moderate, or severe based on GCS, they found no statistically significant link between the patient's age and the severity level.
So a 70-year-old wasn't significantly more likely than a 30-year-old to have a severe initial TBI in this group.
According to this data, no, not in terms of that initial GCS score. It suggests that for this population, the patient's age wasn't the deciding factor for ending up in that severe category. The focus really shifts to how they got injured.
Okay, so if age wasn't a key driver here, let's pivot right to that. The mechanism of injury. What were the main causes in this study?
All right, 4 main causes covered most cases. Number 1, the most common, was road traffic accidents, RTAs. That was 37.1%.
Nearly 2/5.
Yep. Then came falls from height FFH at about 24%.
Okay.
After that, injuries from violence. Blast injuries accounted for nearly 17%, and bullet injuries were 13%.
Right, RTA was most common. But does being the most common cause mean it leads to the most severe injuries, or is there a mismatch?
Ah, that's the crucial point. Frequency doesn't equal severity here. When you isolate just the patients who had severe TBI, remember, GCS 3 to 8, the picture changes dramatically.
Oh, so?
The penetrating injuries, bullets, and blasts were way more likely to result in severe TBI.
Give us the breakdown on that.
Okay, get this. For patients with a bullet injury, a staggering 55.7% of them had severe TBI, more than half.
Wow, that's huge.
It really is. Next were blast injuries. 35.4% of those cases were severe.
Still very high.
Definitely. Now compare that to the blunt force trauma, RTAs, 24.7% severe. And falls from height actually had the lowest rate of severe TBI at 21.4%.
So even though falls were the second most common cause, they were the least likely of these four to result in a severe injury classification.
Exactly. It really highlights the difference in impact. Blunt force, like in a fall or many RTAs, causes more diffuse damage, while high-velocity penetrating trauma, like a bullet, causes devastating focal damage.
So the mechanism of injury is clearly a massive factor in predicting severity.
Overwhelmingly important, yes. The type of force, the velocity. It sets the stage for how bad things are likely to get right from the start.
Okay, now let's look beyond the head injury itself. What about damage elsewhere in the body? Associated injuries, do they play a role?
They did, a significant one. The study found that pretty much all associated injuries damage anywhere else were significantly linked to having a severe TBI. The p-value was less than 0.05 across the board.
What kind of associated injuries were common?
Well, skull fractures were seen in about a third of patients, 32%. Facial injuries were also common, around 28%. Extremity injuries, broken arms, legs, that sort of thing, about 24%.
Okay.
And then a bit less common, but highly significant, were thoracolumbar fractures. That's the mid and lower spine. Around 11% had those.
And a spine fracture suggests a really high-impact event, right?
Absolutely. It signals that the force was immense, enough to damage major structures far from the initial head impact. It points towards multi-system trauma.
And what happened when patients had multiple associated injuries?
The severity rate climbed even higher. For patients noted as having combined injuries, the rate of severe TBI jumped to 39.3%.
So the total burden of trauma across the body is almost as predictive as the mechanism itself.
It seems that way. It suggests a strong link between overall trauma load and the severity of the brain injury.
And this kind of widespread trauma often triggers clinical warning signs, things doctors can measure quickly. What were the big red flags identified in the study, clinical or radiographic signs?
Yeah, this was another area with extremely strong correlations. P-value less than 0.001, so highly significant. Two clinical signs really stood out.
Which were?
First, weakness and paralysis. If a patient presented with those, 57.1% of them had severe TBI. That's a major neurological red flag.
Okay, over half. What was the other one?
The other was hypotension, critically low blood pressure.
And how strong was that link?
This number is truly striking. 83.3% of patients who were hypotensive had severe TBI.
Whoa, 83%. That's almost everyone.
It's an incredibly strong predictor, a signal that demands immediate aggressive action. The source suggested hypotension in TBI usually results from severe bleeding somewhere in the body, or it could be a consequence of a spinal injury affecting blood pressure control.
Both indicating massive systemic problems.
Exactly. Catastrophic system failure, basically.
So this really underlines a key point, doesn't it? A TBI might not always have obvious external signs initially, but if you see these specific clinical indicators, weakness, paralysis, and especially low blood pressure, the odds of a severe, life-threatening outcome just skyrocket.
It really has. It shows how interconnected everything is in severe trauma and why that rapid full-body assessment in the ER is so vital. Like they say, time is brain and, well, blood pressure is life.
Okay, so we've covered a lot of ground looking at the data from this Baghdad study. Let's try and bring it all together. What are the absolute key takeaways for you, the listener?
Right, let's summarize. Based on this study, the severity of a TBI seems significantly linked to, well, four main things. First, the mechanism of injury. Penetrating trauma, like bullets and blasts, carries the highest risk by far.
Got it.
Second, the presence and type of associated injuries elsewhere in the body. More trauma equals higher risk of severe TBI. Third, those critical clinical signs we just discussed, particularly weakness, paralysis, and most powerfully, hypotension.
Okay.
And fourth, in the study population, being male was associated with a higher frequency of severe TBI.
And just as important, what was not a major factor?
Age. In this specific group, the patient's age wasn't found to be a statistically significant predictor of landing in that severe GCS category initially.
So putting this into a real-world context, what did the study authors recommend based on their findings, especially thinking about prevention?
Well, they focused quite logically on the most common causes, even if they weren't always the most severe ones. So road traffic accidents and falls from height.
Makes sense. What do they suggest?
For RTAs, pretty straightforward stuff. Stricter traffic rules, better safety measures, and specifically enforcing helmet use. They actually noted a lack of concern about wearing helmets in the community they studied was a real problem.
Right. And for falls?
Again, fairly practical things, more attention to safety around heights, things like putting up proper walls or railings around roofs and along staircases to prevent those kinds of falls. Basic safety infrastructure.
Essential steps, definitely. But, listening to all this, especially the strong link between severe TBI and having multiple other injuries, it makes you think. The data shows multi-system trauma is often part of the picture in severe cases. So it leads to a broader question, doesn't it? Beyond helmets and railings, which are crucial.
Yeah. What else?
What wider changes, maybe in infrastructure, vehicle design, emergency response, or broader policy shifts might help reduce the chances of someone getting multiple devastating injuries from just one single event, like a bad car crash?
That's a really important question. Thinking about the whole system, not just isolated risks. How do we make the entire event less likely to cause catastrophic multi-system damage?
Exactly. A complex challenge involving engineering, policy, public health.
Definitely something for you to mull over.
Yeah.
How do we design for better outcomes when trauma does occur?
Food for thought. We'll leave you with that question until our next deep dive.